So what happened in the operating system? Operating system works whenever there is an event occur in the system, and there are different type of event that could be occur. And this operating system works means operating system is associated with different type of programs, different type of you can say handlers, different type of device drivers, and different processes related to how we can schedule the process, how we can schedule the CPU, how we can schedule the hard drive. So all these things are there. Inter-process communication, how it will go. When we have concurrent processes going on, then how it will go. So all these things will be taken care by the operating system. And in this, whenever it will detect any sort of events, then only that operating system will act. And these events are called interrupts. So in operating system, these events are called interrupts. So if we'll take this example, as we know that we have two type of modes. One is the user mode, another is a kernel mode. So kernel mode is also called system mode or supervisor mode. So we have two type of mode, user mode and kernel mode. And it shows a privilege level in the CPU. So in the Intel architecture or in any defined XV6 type of CPU or x86 type of CPU, we have different privilege level that is defined. In the privilege level 3, user process is going to execute. And the user process could be your any type of program or any type of application program. Let's say any application program we are running, let's say we are running with the Word doc. Let's say we are using Microsoft Office Word, and we are making a document, and after that, after completing the document, I just have to print it. So what happened to the printing? The printing required the IO devices, right? So when this IO device is required, your event has occurred, means we have triggered a event here, and this particular event is nothing but related to the operating system, because the operating system know where the device driver of the printer is, from which particular USB or which particular network it is connected. So it will send this particular privilege to the kernel mode, and this kernel mode works on number 0. And in this, actually operating system is going to execute. And after the execution of operating system in the kernel mode, again mode has been changed, and any other application program or the same application program is going to run again. So this is how your interrupt will be handled. So interrupt always will handled by the operating system. And because of these interrupt, we actually run the processes inside the operating system, or the programs inside the operating system. So as these interrupts are nothing but different type of events, let's talk about different events in computer system. So the event has been categorized as hardware interrupts. So the first event is called hardware interrupt, or just called interrupts, arises by hardware devices. They are asynchronous and may occur at any time. So what it is saying that the hardware interrupts, which is produced by the hardware, is just called the interrupts. And these interrupts is asynchronous in nature, means can occur anywhere or anytime during the program execution. And these type of interrupts could be generated by any type of hardware associated with the computer system. Next event is called traps. So sometimes it is called software interrupts. The traps are called software interrupt. What is a trap? It is rises by the user program or user applications. What user mode in which we run in the user mode, and it invoke the operating system functionality. Let just I told you, let's say we are running a Microsoft Word and we need to print that particular document. So that user program, which is a Microsoft Word, will rise a trap which will invoke the operating system functionality so that it will work with the device driver of the printer. That is called traps. Then we have exceptions. This is actually generated automatically by the processor itself as a result of an illegal instruction. And what are the different illegal instructions which will cause fault and aborts? Fault could be occur and it is a recoverable error. This could be occur due to the page fault. Now, what is a page fault? See, what happen is whenever we want to run any application or whenever we want to run any program, so that program is divided into number of pages, and these pages are stored in the main memory, and these main memory has different pages, like we have seen in the previous classes, the word. So you can say that one word, one page. In that way, the pages are there. And whenever the CPU require a page, it will ask for the address of the page by the address register, and it will be loaded into the data register, and the CPU will going to execute it. If other pages which is required by the CPU was not there in the buffer or in the cache memory, so it will generate a fault that is called page fault. Okay, and that could be recoverable. How it could be recoverable? It is in the process of finding out the page in the main memory, and then it will again load into the cache memory, and from the cache memory the CPU will get that particular page. So this is how this page fault could be handled, and it is a recoverable, that is called fault. Another exceptions generated by the CPU is called aborts. It will happen to those codes which is difficult to recover, like divide by zero, or we are looking for a memory location which is not there. So these type of error could be occur during the program execution in the CPU, and that is generated by the CPU. Now we are actually looking for faults, or we are learning actually about the faults. So in today's lecture, we are going to learn about hardware interrupts and software interrupts. So we have different type of interrupts, which is called software interrupts and hardware interrupts. And these two interrupts we are going to see today in today's class. So different events has been classified. Like the first event is the interrupt, which is because of the hardware. So it is in the category of hardware interrupt. The second event is called traps. It is generated by the software, so it is called software interrupts. And there are exceptions which is generated by the CPU during the program execution, and that is in the category of faults and aborts. Faults are recoverable, aborts are non-recoverable exceptions. Let's talk about hardware interrupts. So hardware interrupts could be occur by any type of hardware. Here in the example, we have a keyboard. So whenever we press any key in the keyboard or with the keystroke, the signal will be generated, and this signal will go into the processor with a pin which is called INT pin. So processor is associated with the interrupt pin, one interrupt pin, that is called INT pin. So let's assume that processor is processing any program. Either it is a operating system program, that is system program, or it is an application program. So processor is running some sort of programs. Whenever it finds out any type of hardware interrupts, because hardware interrupts has more priorities. It has to be handled as quick as possible. So whenever it get the hardware interrupt, it will save the status of the current executing program, and it could handle the interrupts generated by the hardware, and it will do that with the help of interrupt handler routine. Let's go into the detail that how a processor will handle any hardware interrupt. So for handling any type of hardware interrupt, like for the interrupt generated by the keyboard, we have keyboard interrupt handler routine. This particular keyboard interrupt handler routine has all the functionality written here, that how you will handle this particular hardware interrupts. The code is here inside. So whenever the processor will get the interrupt of the keyboard, it will look for the keyboard interrupt handler routine and it will execute. At the end of the execution, it will get irate. Irate is interrupt return. This particular interrupt return function will take the processor to the same program where it has been stopped the processing. So from the same location, the previous program is going to execute. This is how your interrupt could be handled inside the processor. Now there are different type of hardwares which can generate the interrupts. So there might be the system clock which is generating the interrupt. There might be the USB port which is attached with any type of hardware which may generate the interrupt, or there could be the keyboard, there could be the mouse, there could be the printer. There are different type of hardware, right? And all these hardware is attached with a interrupt controller. That interrupt controller will handle all those interrupts based on their priorities. And this interrupt controller will give this particular signal related to any type of interrupt that has been occurred due to different hardware to the processor through INT pin. And the processor will produce the acknowledgement that I have received the interrupt signal, or I have received the interrupt. And this processor will look for different type of routine. So let's say if it is generated by the timer or the clock, it will look for timer interrupt handler routine. If it is generated by the USB, it will go for USB interrupt handler routine. Or it is generated by the keyboard, it will look for keyboard interrupt handler routine. Interrupt will be handled by the interrupt service routine, interrupt handler routine, which is inside the main memory and which is the part of the operating system. Now let's see in detail what will happen to this interrupts and how this interrupt could be handled. Now this particular part, which is called interrupt controller in the computer program, that is called programmable interrupt controller, that is called PIC. That is called PIC. Let's see this PIC, how it look like. So this is called PIC, programmable interrupt controller. Now in different systems, it is controlled by a microcontroller which is called 8259 microcontroller. Here we have 8 number of inputs and it will produce one output, and this one output will go to the CPU, that is INT, through the INT pin. Now here we have 8 number of pins which will be handling by different type of hardwares. So we have 1, 2, 3, 4, 5, 6, 7, 8 input. So we have different type of hardware that could be handled. Either the hardware could be your clock, or it will be your keyboard, or it will be your mouse, or it will be your USB, or it will be your uh, network card, which is called NIC, network interface card, or it will be a printer, or it will be some sort of monitor or joystick or any type of others related hardwares. Okay. Now here we have 8 pin. So one pin is connected to one particular hardware. There could be a possibility that we have more than 8 hardware associated with a system. So we have an architecture in which we can have more than one 8259 microcontroller. In this particular scenario, one will become master, another will become the slave. So here also we have 8 inputs and one output. This one output will go here in the master. So in that way, if we have two 8259 PIC, so we can handle at a time 15 hardware could be handled. If we have more than 15, then we have more provision. So it depends upon what type of hardware you have and how many USB port they have given. Based on that, they will put the 8259, this microcontroller, which is called programmable interrupt controller. This programmable interrupt controller will handle or will manage all those hardware interrupts, and it will be giving the signal based on the priority of the hardware to the CPU. Now what CPU will do? CPU will look for the interrupt handler routine, and where the interrupt handler routine is, let's see this. So we have our main memory. This is our main memory, and inside the main memory we have two sections. So one is your operating system section or your kernel section, where your all the related application operating system related programs are there, and we have user program or user space, okay, in the main memory. So whenever your system boots, after the booting, your operating system will be loaded into the main memory, and here you will find many interrupt handler routines. There are many interrupt handler routine inside this particular space, and these particular space has different addresses, okay, where your interrupt handler routines are there. These addresses are there inside the register of the CPU. So we have a register. We have a register inside the CPU. That particular register is having different type of addresses. And this particular register is called interrupt descriptor table register. So we have in short, it is called IDR. This is interrupt descriptor table register. Inside that, we have tables of different addresses. So these are all your interrupt descriptor table, which is inside the interrupt descriptor table register. And this particular register you can find inside the CPU. Now what will happen, this 8259 will generate a signal, and through the signal it will give IRQ number to the CPU. This IRQ number is nothing but interrupt request number. This interrupt request number will be generated by this 8259 and given to CPU. So inside that interrupt request number is there. And this interrupt request number, through that, it will map the address. This is a number. Let's say we have a number 0, 1, 2, 3, 4, 5, 6 in that table. Let's say the interrupt number is 1 or 2. So it will go to the location of the 2 and it will get the address. Here it will get the address. Address of what? Address of interrupt handler routines. From here, the address will go into the address register, which will have the address of the main memory, where it will find out the interrupt handler routine. And this interrupt register will give this particular, address register will give the address to the main memory for getting the interrupt handler routine. And in that way, it will find out the interrupt handler routine from here and load into the data register. And this particular data register will be given to the CPU, and CPU is going to execute that particular interrupt handler routines. And in that way, the interrupt handler routine will be executed. And after that, at last, every interrupt handler routine will have IRET, which is called interrupt return. This particular interrupt return will take to the previous locations or previous state where your data is, previous program was there. Okay. So this is how your interrupt will be handled by the CPU, and that is related to the hardware interrupt. This is how your hardware interrupt will be handled. These are different type of interrupts and exceptions in Intel x86 architecture of CPU. You see, we have around 56 type of interrupts available. Top 20 interrupts are related to all different faults and all different abort and different type of traps and all. After that, 21 to 30 will be related to the Intel reserved. So it is related to the Intel itself, Intel architecture, and it is reserved for that. So these 10 interrupts are for that. And from 32 to 255, it is user defined interrupt. And that is the combination of hardware interrupt and software interrupt. So we have 256 interrupts available, which is hardware interrupts and software interrupts. So our system can handle 256 interrupts. That is the combination of hardware interrupt and software interrupts. Okay. So now we have gone through the hardware interrupts. Let's go to the software interrupts. Now what happened into the hardware interrupts? There is a devices which are generating the interrupts. These interrupts will be given to the PIC, programmable interrupt controller. This programmable interrupt controller will generate the IRQ number and give this IRQ number to the CPU through interrupt pin. This particular, through this IRQ number, CPU will find out the interrupt handler routine from the main memory and execute that interrupt handler routine inside the CPU. And then at last, it will get the interrupt return, by which it will go to the previous state from where that interrupt has occurred. So all these hardware devices are attached with the PIC, programmable interrupt controller. In advanced systems, or in you can say nowadays systems, we have advanced programmable interrupt controller, which is called EPIC. This EPIC is responsible for handling all type of interrupts that could be occur, all type of hardware interrupt that could be occur into the CPU or into the system. Now let's go to the software interrupts. So what happened into the software interrupt is, software interrupt will be generated by an instruction which is called INT, interrupt. This particular INT instruction will be executed inside any application program or inside any type of program. So if this particular instruction will be occur, the software interrupt will be occur, means a trap will be generated. Trap is nothing but software interrupt. So that trap will be generated and mode will be changed to from the user mode to the kernel mode, and related operating system exceptions is going to execute. So let's talk about the software interrupt in detail. We have different type of software interrupts. Those are, let's say, if during the program we want to read the file, or during the program, let's say we want to write onto the file, or let's say we want to display any data to the monitor, or let's say we want to send any packet through the network. So, or there are many others. So if we want to do all these things through the program or through the application program, so that particular, all these are called software interrupt or trap. Generally, software interrupt is used for implementing system calls. So the software interrupt could be handled through the system call. Okay. So whenever we got any software interrupt, it is calling the system call, or it is looking for the system program, which is called system call, and it is generating the system call. So in the same way, we have different system programs, and all these system programs will be run through the system call. Now in the Linux architecture, INT28 instruction is used for the interrupt or system call. In XV6 type of operating system, INT64 is used for the system call. So there are INT instruction, but here in the Linux it is called INT128, and in different operating system which is based on XV6, in that it is called Intel 64. Let's say we are talking about XV6 operating system. We have a process which is going on. Let's say we have a software or we have an application program which is running, and it is running in the user mode, which is in the level 3. Whenever it got a interrupt instruction, which is interrupt 64, means it is related to XV6 type of operating system. In that, the mode has been changed to the kernel mode, and the kernel program is going to execute based on the system call. So here the mode is the user mode, and here the mode has changed to the kernel mode. Now let's see different type of the system call. So we have the category of different system call. Let's say the system call related to the process control. We have, when we create a process, when we terminate the process, these are all related to operating system or the kernel. Okay, so it is a system call. And the process aborted, load the process or execute the process, get process attribute, set process attribute, wait for time, wait event, signal event, allocate and free memory, dump memory or error, if error, debugger for determining bugs, single step execution, logs for managing access for shared data between processes. So all these are different type of system calls inside the process control. Now let's go to the file management. We have create file or delete file, open file or close file, read, write or reposition the file, get and set file attribute. All this system call is associated with file manager. Then we have Device manager, let's say it is requesting for any device, release device, read or write reposition, get device attribute, set device attribute, or logically attach and detach devices. Next is information maintenance, get time or date from the system, set time or date of the system, get system date, get system or set system date, get and set processes, file, device, and attributes. Communication, create, delete, communication connection, send and receive messages through NIC cards and all, share memory model, create and gain access to memory region, transfer status information, attach and detach remote devices. Or we have system call related to the production, like control access of the resources, get and set permission, allow and deny user access. So all those are different type of system calls. Like in Windows, related to the process, file, device, information, communication, and protection, different system calls are there. These are all system calls. You can see all are look like function call, right? So these are system call related to the Windows, and these are system call related to the Unix operating system. These are all the different system call. Just now we have seen some of the system call with the interrupt, and this particular interrupt is in the category of software interrupt. It will generate the interrupt routine. Then your user mode will be changed to the kernel mode, and the interrupt will be handled by the interrupt handler, or you can say the system call where it is, and it will go to that particular exactly the system call and execute the system call. After getting IRET, it will be returned back to the same place from where this particular state has been changed, and it will execute the next instruction into the program. So this is how your software interrupt will be executed. So exactly what will happen and how a system will get into the system interrupt, like we have different type of system calls, right? So how a system will identify that which particular system call we are looking for. Either we are looking for fork, or we are looking for exec, or we are looking for change directory, or we are looking for change mode. Which type of system call we are looking for. So what happened in your routine, uh, these two lines will be there. Let's say just before the interrupt instruction, there is instruction called move x percentage eax. Here eax is nothing but a register. There is a eax register. In this eax register, we are going to store a number which is called x. This particular x is depend upon the system call, and it will find this particular number in system number call. So we have different system number which is associated with different this system call which is associated with different numbers, and these number will find out in this particular files, syscall.c file. In that or syscall.h file, you'll find this particular definition. This particular definition is associated with different system calls, and through that particular number, what will happen is whenever this instruction 64 will be executed, the control will go to the EAX register. Inside the EAX register, it will find out the number. That particular number is associated with the system call, and from the system call, it will find out the system call handler. This system call handler will take it to the system call, actual system call, and the system call will be executed. So here also, all these system calls are there inside the main memory, and it is going to execute inside the main memory. I've gone through different type of system calls like make directory, or make node, or change directory and all. Open the file, read file, and write file in C, C++. We have seen all these things. Later on, we are going to understand a different system call like fork and exec. That we'll see later. Let's see what happened actually when this software interrupts occur. let's say we are executing a program, and inside the program this line came which is saying to print any string into the console. So what will happen here in this particular library of C is going to execute it, and it will find out associated routine of print, that is write. stdio is the routine handler for this particular write operation.